Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 21 to 24 of the June 2019 Algebra 1 New York Regents exam. This is a thorough coverage of the problems, so we're going to explain the problems in a step-by-step fashion. If you feel that it's not fast enough for you, do visit our website at mathgotserved.com under New York Regents, and you will gain access to the transcripts of this video, and you can go through it at your own pace. Don't forget to subscribe to our channel so you can get updates to a wide variety of math tutorials we upload to our page on a daily basis. Alright, let's take a look at question 21. On problem 21, we're being assessed on how to solve quadratic equations either by factoring or by the quadratic formula. Question 21 reads, the roots of x squared minus 5x minus 4 equals 0 are, so we have four options here. Okay, now what you will notice if you inspect the options is that the options 1 and 3 indicate that the roots are rational. Okay, remember, rational numbers do not have radical components in their simplest form. And option 2 and 4 indicates that the solutions are irrational. Okay, so let's make note of that. So option 1 and 3 are rational roots, and then option 2 and 4 are irrational roots. Okay, so what does this mean? Well, the nature of the roots basically tells us the approach that we can use to solve the problem. Okay, so option 1, if the roots are rational, guess what? That tells us that the polynomial expression is factorable. So you can basically use the factorization method, namely the X game, AC method, whatever you call it. You can actually factor the polynomial expression and use the zero product property to solve it. If the answers were 2 or 4, which are irrational roots, that basically tells us that the polynomial is not factorable. Okay, is not factorable, or you can refer to it as being prime. Alrighty, and in this particular case, we have a scenario where the polynomial is not going to be factorable. You can't use that, so you have to resort to another method, namely the quadratic formula, or completing the square, or you can use a calculator. Alrighty, okay, so the question is, can you determine if a polynomial is factorable or not without actually going through the entire process? And the answer is yes, absolutely, we can do that. So what I'm going to do first here is I'm going to show you how to test to see if a polynomial is factorable or not, or if the roots are rational or not, which is connected. Okay, alright, so we have the polynomial x squared minus 5x minus 4 equals 0. So what we're going to take a look at is we need to determine the value of a, b, and c. Alrighty, so we have the invisible coefficient here, which is 1. Remember, if you don't have a coefficient, the default coefficient is 1. So a is 1, and then b is -5, and then c is -4. Alright, let's go ahead and write it down. So we have a is 1, b is -5, and c is -4. What we're going to do now is we're going to carry out a test. Okay, I'm going to call it the test for factorability. This test basically tells us the nature of the roots. It's like a predictive instrument. With just this test, you can tell if your roots are going to be rational, if they're going to be irrational, if they're going to be imaginary or real. It's an amazing test. Okay, alright, so for the test of factorability, or the nature of the roots, we're going to look at this terminology right here, b squared minus 4ac. If you think about your quadratic formula, the portion of the quadratic formula underneath the square root is called the discriminant. Okay, the discriminant is b squared minus 4ac. So this component can tell you a lot of information about the roots. Okay, So let's just focus on factorability right now, and let's note the following piece of information concerning the nature of the roots and the discriminant. All right. So if b squared minus 4ac, which is the discriminant, if the discriminant is not 0 or a positive perfect square, guess what? If it's not 0 or a positive perfect square, then the polynomial expression is not factorable. All right, is not factorable. And guess what that means? Since it's not factorable, or you can say it's prime, that basically means that the roots are going to be irrational. Roots are going to be irrational. Alright, the roots could be imaginary too, but in this particular case, we're just focusing on it being rational or irrational. Alright, so if b squared minus 4ac is not 0 or a positive perfect square, then the answer will either be option 2 or 4. Okay, but if b squared minus 4ac is 0 or a perfect square, like 4, 9, 16, then the answer will be option 1 or 3. Okay, so with that in mind, let's do the test. So in this particular problem, we know what a, b, and c are. So let's compute what b squared minus 4ac is going to be. So b is what? Negative 5. B squared minus 4. A is 1. C is negative 4. Alright, so what we're going to do now is we're going to use Pemdas. Alrighty? Please excuse my dear Aunt Sally to simplify this expression. So we have an exponent here. We need to take care of that. Negative 5 times negative 5 minus times minus is plus. 5 times 5 is 25. So we have 25 minus. Now we can multiply these right here. 4 times 1 is 4. And then that's times negative 16. All right. I mean times negative 4. Okay. Continue with Pemdas, 25. We have to multiply before we subtract. 4 times negative 4 is negative 16. And then if we multiply minus times minus, that's minus times minus is plus. Remember, whenever you multiply two signs that are the same, your product is always going to be plus, okay? 25 plus 16 is 41. Is 41? Is it a perfect square? The answer is no. Okay, let's go over perfect squares real quick. So we have 1 is a square, 1, and then the next square is, so let me just show you. So 1, and then 2 square is 4. That's the next one. 3 square is 9. Next one, 4 square is 16. 5 square 25. 6 square is 36. 7 square is 49. Bam, we exceeded 41. 41 is not on this list. 41 is not a perfect square. Okay, so what does that tell us? If the discriminant, or b squared minus 4ac, is not a perfect square, then that means that the polynomial cannot be factored. Okay? Alright, so 41 is not a perfect square. So that means that the polynomial cannot be factored. If it cannot be factored, that means that the solution is not going to be rational. So based on the value of this discriminant that we have right here, guess what we can do? We can eliminate options 1 and 2 because they are rational and they require the discriminant to be 0 or a perfect square. Okay, now another way you could do this, if you don't like this b squared minus 4ac business, you can always just try and factor it out. Okay, just try and factor it out. So let's just act as though we don't know what's going on, and we just blindly try to do the X game or the AC method, whatever you call it. We put AC on the top and put B on the bottom. AC is negative 4 and B is negative 5. And we ask ourselves, what two numbers multiply to give you negative 4 and add to give you negative 5? Okay, so if you try 1 and negative 4, does that work? It gives you the top, but it doesn't add to give you the bottom. Okay, how about we make both of them negative? Negative 1 and negative 4. If you do negative 1 minus 4, you get negative 5. It works for the bottom, but negative 1 times negative 4 is positive 4, which doesn't match the top. Okay? So there is no combination of 1 and or 4 that is going to yield the top and the bottom values. So the X game in this particular case fails us. Alright? So it fails. So what does this tell us? In the bigger picture, this tells us that the X game, the factorization method, does not always work. Please keep that in mind, okay? So that's why you need to have a backup plan when you are solving quadratics, okay? All right, so something to keep in mind is that the quadratic formula can solve all quadratic equations. Isn't that something special? This is special because what this is telling us is that the quadratic formula never fails. As we can see here, the factorization method fails, but the quadratic formula never fails. All right. So if you know your quadratic formula, you're in a good shape, and you also know how to use it. So let's write down what the quadratic formula is. What we're talking about. Quadratic formula is x equals negative b plus or minus the square root of b square minus 4ac, b square minus 4ac, and the entire thing, not just the radical component, the entire thing all over 2a. That, ladies and gentlemen, is your quadratic formula, and it always works. Okay, so what we're going to do is we're going to go ahead and use this quadratic formula to find the roots, since the factorization method has failed us. So we're going to have x equals negative b, so b is negative 5. We already have our negative b here. Negative 5 minus negative 5. Alright, you got to be really careful with your negatives. That's why when you're making a substitution with a negative number, always use parentheses for safety reasons. Okay, so minus negative 5, so a lot of students will forget that sign there and then they'll fall into a trap. So be careful with that. Alright, so minus negative 5 plus or minus the square root. Okay, wait a minute, hold on. B squared minus 4ac, this radical component of the quadratic formula, have you seen it earlier? Yes. It's the discriminant is exactly the same as this right here. Okay, what we use to determine the nature of the roots. We already used b squared minus 4ac. We already know what it is. B squared minus 4ac is 41. Okay, so we already started the process before we even actually knew it, right? So guess what? We are just simply going to take that value of 41 and put it in here. We don't have to do the work again, with just waste of time. So just plug it in here. Bam. We're done with that portion. The whole thing divided by 2a, which is 2 times 1. So we're just going to Pemdas this expression, not all the way, just simplify it as much as we can, and then we should be good to go. Alright, so this is going to become minus times minus. When you multiply the same signs, you have positive 5 plus or minus the square root of 41. We can't simplify it because if you look at the options here, it's not simplified, divided by 2. Alrighty, so if you look at the options that we have here, we can clearly see that the answer to question number 21 is option number 2. 5 plus or minus the square root of 41 over 2, okay? So this is basically how you use the quadratic formula and the discriminant to find the nature of the roots and also to find the roots of a quadratic equation. So let us know what you think. Do you like the quadratic formula? Yes or no? Post your response in the comment section below and tell us why. Why do you feel the way you do about the quadratic formula? Alright, let's take a look at question number 22. In question 22, we are going to be assessed on how to find the standard deviation of a data set using the Texas Instrument calculators. Okay, so question 22 reads, the following table shows the heights in inches of the players on the opening night roster of the 2015-2016 New York Knicks. So you have the roster here. Okay, question, the population standard deviation of these data is approximately. Alright, so let's go ahead and fire up our calculators. Alright, so what we're going to do first is we're going to enter the data set into our calculators. Okay, so press the stats button right here, hit stat, and then edit. Alright, the first option, edit, we're going to be entering the data set into list 1. Okay, so I have something stored there previously, so all I'll just do is delete, just delete everything out of there. Okay, so I have everything deleted, so all you just do is you just enter the data set into the first column, list 1. Okay, don't go into any other list. So 84, let's get started, 84, and then 80, 87, you just enter the number 75 and then hit enter. Okay, I'm using my keyboard to enter it here because I'm using a computer. 84, 80, 87, 75, and then 77, 79, 80, 74, 76, 80, 80. Oh wait, I did 90. So 82, enter, and 82. Okay, so when you're done entering the data into your calculator, something that I strongly recommend is that you want to go through the entire thing. Okay, now if you look at the last number, it says L13. What does this 13 mean? Well, it tells you the sample size, how many pieces of information you entered. Okay, how many elements are in your set. So this is a good way to check to make sure you didn't leave anything out. So it says L13, so how are we going to check to make sure that we didn't leave anything out? You just count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have a match. Okay, so you always want to do that. Make sure you didn't leave anything out before you start calculating. Okay, so we've checked the numbers, and then let's just go over the actual values. Alright, even though we have 13, it doesn't mean that they're all correct. So let's go over the actual values again, just to ensure that every entry is accurate. 84 check, 80 check, 87 check, 75 check, 77, 79 check, 80, 74, 76, 80, 80, 82, 82. Perfect, we have everything entered. Okay, so now press second function quit to go to back to the home screen. Now what we're going to do is we want to calculate the standard deviation. So to do that, we're going to press our stat or statistics button again. So when you're doing things like standard deviation, mean, things like that, average, just statistics. Okay, so press your stat button. You have edit calc tests in the menu. Alright, so you scroll to the right to take you to the calculate menu for calculations on the data set you have in the data set field. This is just one variable, so we are going to be doing one variable statistics. Okay, so the only thing that's varying here are the heights, so that's one variable statistics. So have one variable stats highlighted, press enter. Okay, one variable stats shows up on the home screen, and then press enter again, bam, and it gives you all these things right here. Okay, what on earth is that? Well, let's go ahead and talk about what each of these values represent, and then we can easily select what our correct answer is. Alright, we're going to start from the top. The first one represents the so one variable stats is what we called to do the calculation. So x bar represents the sample mean. Okay, so x bar is the sample mean. And then we have this Greek alphabet right here, sigma x. Sigma represents sum. Okay, so sigma x basically is the sigma x represents the sum of the data values. Okay, sum of data values. So if you want to find the sum of all these numbers that you entered, it's going to be 1036. Nice, right? And then next we have sigma. Remember what sigma means. Sigma represents sum. Sigma x squared. Can you guess what this means? This simply means the sum of the square of the data values. Okay, sum of data of squared data values. Okay, sum of data values squared. So if you square the data values and find the sum, you are going to get 82,720. Alright, what does this S of x mean? This S of x right here represents your sample standard deviation. Okay, so this S of x is your sample standard deviation. So is that what we are asked to calculate? The question says, what is the population standard deviation? All right, let's look at the last one. Okay. All right, so if we take a look at the last, second to the last output value, it's this weird symbol right here. Okay, this weird symbol is a lowercase Greek alphabet. It represents the Greek alphabet sigma. Okay, you see this e's that we have here, those are sigmas too. These sigmas, uppercase sigma is represents sum, okay, in the Greek alphabet, but lowercase sigma represents standard deviation. Okay, so lowercase sigma in this particular output table we have right here represents the population standard deviation. Alright, and then our last value, n equals 13. Do you know what that is? Remember we talked about 13 earlier, right? What does that n value mean? That n value represents the sample size. How many data elements do you have in your set? Okay, your sample size, and we counted it earlier, there were 13. So n equals 13 should not surprise us. Alright, so based on what we have here, what is our answer? We are looking for the population standard deviation, which is this guy right here, lowercase sigma x. So let's write down our answer. The population standard deviation is sigma x, which is 3.494712. If we want to round it to the 10th place, okay, it's going to be 3 points. Now we're rounding it, this is the 10th place right here. Bam. Alright, so you draw a line, you look at the number behind. If it's 5 or greater, you round up. If not, you stays the same. Alright, so this is 5 or greater, so we're going to round up. Put plus or minus. We're going to round up, so we're going to be adding 1 to this 4 right here. So this value rounded to the 10th place is 3.5. Alrighty, so ladies and gentlemen, that is the population standard deviation of this data set. The answer to question number 22 is option number 1. Alrighty, so that's basically how to find the standard deviation using a Texas Instrument calculator. So we'd like to know how you would rate the level of difficulty of this process. How would you rate it? Would you rate the level of difficulty of finding the standard deviation using the calculator as being Low, medium, or high? Let us know what your rating is in the comment section and tell us why you gave the rating that particular value, okay? All right, let's take a look at question number 23. All right, in question 23, we're going to be learning how to read radioactive decay models. Basically, can you identify the amounts, initial and final amounts, the rate, and the time given a radioactive model in symbolic form? All right, so that's what we're being assessed on this question. Question 23 reads, a population of bacteria can be modeled by the function f of t equals 1000 times 0.98 raised to the t, where t represents the time since the population started decaying, and f of t represents the population of the remaining bacteria at time t. Question, what is the rate of decay for this population? So looking at this model, radioactive decay model here, can you tell what the decay rate is? Alrighty. So in order for us to do this, we need to first of all know what the radioactive decay model is. Alrighty. So let's go ahead and write that down. The formula for radioactive decay . Radioactive decay. The formula for radioactive decay is y, or you can call it f of t, y as a function of t is equal to a times 1 minus r raised to the t power, okay? Remember, this minus indicates the sign before the rate indicates the direction. If it's plus, is radioactive growth. If it's minus, is radioactive decay. Alrighty, now what do the different components of this formula mean? A is the initial amount. Okay, A is initial amount. How much material was present initially. R represents the rate of decay. Rate of decay. Now this is extremely important. R represents the rate of decay in decimal form. Okay, it's not in percentage form. In the question, they're asking for the rate of decay in percentage form. But in the formula, R represents the rate of decay in decimal form. So we have to do conversions anytime we're going from percentage to the formula or from the formula to percent. Alrighty, so R is the rate of decay in decimal form. T represents the time, and Y represents the final amount. Alrighty? Okay, so what we're going to do is we're going to place this model next to this formula and see if we can isolate what we want to find. The radioactive decay model for this particular scenario is f of t equals 1000 times 0.98 raised to the t. So can you see what the decay rate is? So if you take a close look at it, you notice that 1 minus the decay rate is what's raised to the t power. Okay, but in this particular model we have 0.98. So what's the connection? 0.98 is equivalent to to 1 minus the decay rate. Okay, so 0.98 is 1 minus the decay rate. So we can use that piece of information to set up our an equation. All right, so 1 minus r, the quantity being raised to t, is equal to 0.98. Now if we solve this equation, then we will be able to know what r is in decimal form, convert it to percent, and we are done. Okay, alright, so how do we solve this? We want to get r by itself. So what we can do is subtract 1 from both sides and then multiply both sides by -1. I hope you see that. Okay, just some straightforward algebraic procedures. Subtract 1 from both sides and then multiply by -1. Alright, let's do it. Subtract 1 from both sides. Okay. If we do that, we are going to get, let's see, it's going to be negative r equals, so 0.98 minus 1. You could do that with your calculator. It's going to be 0. Subtract and keep the sign of the bigger one, 0.02. So we still have a negative here. To address that, we'll just multiply both sides by -1. You can multiply by -1 or divide by -1. It's going to be exactly the same thing. Okay, so so let's multiply by, oh, let me just divide by -1. Looks prettier. So you divide both sides by -1, and then you get r, because minus over minus is plus. R is equal to minus divided by minus, slash and dash, bam, slash and dash. R is 0.02. So is our answer option 4 0.02%? Yay or nay? The answer is no. Why not? We talked about this earlier, that r in the formula is in decimal form. Okay? It's in decimal form. So what we must do is we need to convert this into percent. How do you convert from percent to decimal? I'm sorry, how do you convert from decimal to percent? All you just simply do is you multiply by 100. Okay, so this is decimal. So to convert 0.02 to percent form, we're going to take 0.02 and multiply by 100. What effect does that have? You could do this mentally. Guess what? When you multiply a number by 100, it moves the decimal point 2 places to the right. So you count the number of zeros, and that's the number of movements you have. Okay, so we're going to move a decimal point 1, 2. 2 places to the right. 0.02 times 100 is equal to 2. So 2% is the decimal form of, is the percent form of 0.02. Okay, this process can easily be done with your calculator. If you don't want to go through, if you don't want to do it by hand, just multiply it with your calculator if you're not too sure. So you just go 0.02 multiplied by 100. Bam, and there you have it. Alright, so you can see what the answer is. The answer to question number 23 is option number 2. So this is how to read the different components of a radioactive decay model. Alright, so question for you. How do you normally convert decimal to percent form? Do you normally just move the decimal point, or do you multiply by 100? Let us know your approach in the comment section below, and tell us why you use whichever approach that you do, or maybe you have another cool method that you use. Do share it with us in the comment section. Alright, let's take a look at question number 24. In question 24, we're going to be assessed on how to convert units. Okay? Question 24 reads, bamboo plants can grow 91 centimeters per day. Question, what is the approximate growth of the plant in inches per hour? Okay, so what on earth are we trying to do here? What we're trying to do here is we're trying to convert 91 centimeters per day. We're trying to convert 91 centimeters per day into a value. We don't know what it is, but it is in inches per hour. So what is this value? Okay, if we convert the units from centimeters per day, length per time, to inches per hour, length per time, what would the resulting value be? What would 91 change into? That's what we are going to do here. Okay, all right, so we want to identify what our goal is in this conversion process. All right, so let's identify what our goal is, and then we are going to apply it. So the goal here in our conversion is to cancel or divide out, cancel out centimeters and day. We need that gone. What do we want in replacement? And we want to be left with, inches and hours. Okay, so we're going to use the conversion factors to accomplish this goal. Cancellation of these two units that we don't want, and want to be left with these two units that we want. Okay, so to do this, as indicated earlier, we're going to use something called our conversion factors. If you take a look at your reference sheet, one of them is provided for you. Alrighty, so let's take a look at length first. Length conversion factors. For length, we're looking at centimeters and inches. So if you take a look at your reference sheet, you will see that 1 inch is 2.54 centimeters. So how do we express this as a conversion factor? When you're converting lengths from centimeters to inches or inches to centimeters, you either multiply by 1 over 2.54. So 1 is what? Inches or inch per 2.54 is centimeters. So either you multiply by 1 over 2.54 or you multiply by 2.54 over 1, and this is centimeters per inch. Alright, so these are the conversion factors to go from centimeters to inches or from inches to centimeters. How about our time conversion factor? What do we know about time? Well, we know the following. This was basic information. We know that in one day you have 24 hours. Yes? So how do we write this as conversion factors? For time conversion factors, when you're going from day to hours or hours to day, either you work with 24 hours per day, or you multiply by 1 over 24, 1 day per 24 hours. Okay, so we're going to pick one from the top and one from the bottom in order to convert 91 centimeters per day into inches per hour. Alright, so let's set it up. So 91 centimeters per day. Okay, so first things first, we want to get rid of centimeters and be left with, what do we want to be left with? Day. No, I'm sorry. We want to be left with inches. Okay, so are we going to use this one right here, this one, or are we going to use this one? The one that will cause for the cancellation of centimeters is the one that we are going to use. Centimeters is in the numerator position here. In order for cancellation to happen, we need the conversion factor with centimeters in the denominator position. Okay, so which one do you think we're going to pick, first or second? We are going to pick the first one. Okay, why? Check this out. 1 over 2.54, if we configure it like this, and then we have inch per centimeters. See what happens. Centimeter and centimeter cancel out, and you're left with inches. Voila, that's exactly what we want. Yes. Okay, so this helps us accomplish our length conversion component. The other one is a time conversion. Okay, now we are either going to use 24 hours per day or 1 day per hour for 24 hours. So which one do you think we're going to pick? Day is in the denominator position here, so we want to pick the conversion factor that has day in the what? Numerator position, the opposite position, so they can cancel out. Okay, so we're going to use, what are we going to use? 24, no, wrong one, 1 over 24 day. So it's the units that's basically guiding us here. Okay, the units are our guide, so we're using this one, this guy right here, to accomplish the goal of converting our time from day to hours. You see why we selected that one? Because check this out, days in the bottom here, days in the top there, cancellation. So let's go ahead and show you the cancellation process. This is amazing. Now check this out. For the length, centimeter gone, we're left with inches. okay? For the time, day and day counts divide out, and we're left with hours. So the unit of the product of these numbers is going to be inch per hours. Inches per hour, that is exactly what we are looking for. Alrighty, so let's go ahead and multiply out. So if we multiply out 91 times 1 times 1 as 91, and the unit on top is inches, and in the denominator, let's see, how do we multiply 91 by these fractions? What you do is you express 91 as a fraction. What's the indivisible denominator of all integers? It's 1, okay? So you can put 1 underneath every integer, and nothing changes. Okay, so in the bottom we have 1 multiplied by 2.54 multiplied by 24. And the unit in the denominator is hours. Okay, so when we evaluate this quotient right here, quotient and the product, we're going to end up with what our final answer is. Alright, so we need our calculator to help us out with this. So fire up your calculators. Let's evaluate what this is. So we have, you know what, in order to avoid making mistakes, I'm just going to do it step by step. Okay, so let's do the denominator first. 2.54 times 24. You don't have to put the 1 there because it's a multiplicative identity. It doesn't impact the product. Okay, so 2.54 times 24 is 60.96. You could do everything together, but I'm not taking any chances. I want to break it down so that you can avoid making mistakes. Okay, so 60.96 inches per hour, and then just divide it out. Okay, so you're going to have, what are we going to have? 91 divided by the answer we got, 60.96, and you get 1.49. Alrighty, so it's 1.49. If we round it to the hundredths place, that's the option we have here. It's going to be approximately 1.49 inches per hour. So the answer to question number 24 is option number 1. So this is basically how you convert units, ladies and gentlemen. Alright, so what do you think about this process? Do you think it's difficult or pretty straightforward? Let us know in the comment section below. Do you have a different approach that you use to solve problems like this? If you have a different approach, just post your comment in the comment section below. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful, do let us know by giving us a thumbs up. And if you have any questions, comments, or requests for math problems to be done, just post it in the comment section below and we'll be more than glad to respond. Do not forget to subscribe to our channel. We update our YouTube page on a daily basis. So if you want to get notification of those updates and also notification of the remainder of this review series, just subscribe to our channel. More review resources can be found on our webpage at math.serve.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.